Hello everyone, welcome to my second video. In this video, I'm going to be building on a really important topic that I covered in the first video, which is the importance of well-structured data. And we're going to also be using Power Query to manipulate data that you might receive in long format, such as that from the Fisher Family Trust, and flip it into wide format so you can load it into Sims. I'm also going to give you some heads up to some really useful features in Excel that are available now, mainly Power Pivot, which is part of the Power BI family, and give you more of an insight into how your data actually can be used to best effect within the school. I hope you found the last video useful. Before I go on, I want to again say, ultimately try and get a database system that's going to do everything for you so you don't have to resort to doing it in Excel. The reason I'm saying this to you become more apparent, but before I go on, I just want to say a bit about my motivation for these videos. Big Academy Change, which is like 31 schools, tend to have IT departments with like 5, 6, 7 really highly qualified specialist people that can develop, design, choose, select, and improve the IT systems used in their schools. Small schools or small academy chains don't have this, and they don't have necessarily the technical background within their organizations to help support them. So this video is kind of for you lot really, to try and help you understand more about how you might use your data better, and also to appreciate what systems are out there more. Okay, so I'm going to start with just a brief recap on what we did last time, and to add a few things to that. We looked at wide format data. We looked at how doing analysis on wide format data is difficult, and how if you can get data into long format, it makes life a lot easier. And you can then create dashboards like this one that respond to users simply clicking on a tab on a slicer that changes the data that's being presented. So we're now looking at females, we're now looking at males, we're now looking at just autumn, we're now looking at just maths. What I didn't stress enough is this particular slicer up here, which is kind of key. This allows you to change analysis to be a different subject. The reason it can do that is because you're using long format data that has a column that has got subject on it. So in other words, these slicers that are also available on tables, but are used by charts and by pivot tables to limit the data that the pivot table actually analyzes, are only possible to set up if you've got a column. So, this subject slicer is actually presenting all the unique values that are in the subject column and letting you limit the pivot table and charts to that value. So if I use it here, for instance, this is now just showing maths. It's now just showing maths autumn. It's now just showing action plus kids here, maths autumn. These are only affecting the view of this data that you're seeing. It's not changing the charts in the dashboard. These will change the charts in the dashboard, but they do the same thing. So if I change it to maths autumn special needs only, these charts are now showing you a graphical representation of the list we were just looking at. And this table here, this pivot table, is obviously showing you the actual raw data underneath it. Okay, I hope that makes some of the content from my previous presentation a bit clearer. So going back to wide format briefly, here's a slicer I can add on the wide format that reduces it just to Action Plus. And sure enough, yeah, you can still see their data, but the columns are actually have got different subjects in it. And if we had 10 subjects, it'd be much wider and slightly harder to interact with. But I want to stress that this format is really, really good in many ways, in that I can look at a kid and I can see that kid's data, and I can compare it to others in their group or in their year group. I can sort, I can put the kids with the highest scores at the top of the list with the lowest scores at the bottom. So it's a means of comparing a student, and by creating columns that allow you to sort and filter to get the data you're interested in, it's useful. But when you want to do charts and pivot tables and create solutions like this one, which are generic, which are reusable week on week, year on year, then you need to get your data into long format. And we use Power Query to do that. So just to recap again, we took this data, which was all numeric, and we created a query here that basically took the data from its source, which was the wide format, and converted it to be in long format like this. Now, for those of you that are very observant, you might notice that there's also a textual level here as well as a level. In the last demo, we only had level. Getting that in there is actually really, really difficult, and I don't want to blow on anyone's minds here. So ignore this if it's hurting your head. But what we actually in effect can do with Power Query is take wide format data like this, make it into long format data that's got essentially lots and lots of numeric ones, and underneath it in the same column all the textual levels. And then you can kind of treat those as, instead of one big long table, you can get Power Query to treat it as two separate tables, and then to merge those two tables together to create all the common data on the left, the numeric level and the textual level. Now, for those that are used to databases and lookups and things, you can imagine what might be going on there, sort of joining tables and that sort of thing. But I just wanted to point out that Power Query can do it, and it's a beautiful, beautiful feature if you can get your head around it. And it's this merge step. So this merge step is actually taking data from this list here, which is just the whole data, and this list here, which is just the textual data, and it's joining it and merging it and creating a single list. And eventually, with a bit of jiggery pokery, you can get it to be that. Right. So that is what I would refer to as pretty damn advanced use of Power Query that not many of you are going to need to do, thankfully. But it's worth noting that Power Query can do all sorts of things. And I just did want to touch on kind of an extreme case. But you can rename columns, you can change data types of columns, you can convert data, you can keep just the top 100 rows, you can split column by delimiter and by number of characters, as you would in Excel when you're doing text to columns. You can do group by, aggregations, SQL type stuff. You can do more significant transformations, which I demonstrated, pivot and unpivot. And we're going to do some more of this later. But essentially, you can really grab the data and spin it around and change it and do all sorts of stuff to it to get it in the format you need it to be in. Right, so that's a recap and adding quite a lot at a little bit to what I said previously. So I want to move on to using Power Query to manipulate some data that you commonly find in schools. So, for instance, this data here actually comes from the Fisher Family Trust. It's estimates. I've color coded it. I've moved the columns around, but it is a typical Fisher Family Trust data. And what you can see is it's got multiple rows for student. Again, one row for each subject. And what they're actually providing is an estimate as to what level that child should be at the end of year 9 based on their Key Stage 2 scores, i.e. the end of primary school. And actually these two columns here give you further information about that grade. It tells you that it was calculated using an algorithm known as PA, and that one of the parameters that the school used to create it was 15, which makes it quite a challenging sort of target, but you can adjust that down. There's other data here which we're not going to go into, other than to say we've got test scores from Key Stage 2, we've got teacher assessment from Key Stage 2, and crazy but true, we've got the percentage chance of them getting to every whole level at the end of year 9. I'm not sure what the ones at the end are. So, this is sort of data going to schools that they're ignoring a lot of, and rightly so, because the most important thing is that column. That is kind of the expectation for that child based on their previous performance in primary school as to where they'd be at the end of Key Stage 3 in year 9. And schools kind of are expected to get kids to be as good as that. And okay, a lot of jiggery pokery and politics around it, but let's say that's where they should be. For the purpose of today, we're just going to be using these three columns, and we're simply going to want to load it into Sims. Okay, so I've used Power Query again, and here's actually the results of the Power Query. So you can see it's gone into one row per pupil, one column for every subject row, and the actual target there. And I'm going to show you how that's achieved in Power Query. It's actually really, really simple. It's just 3 steps. So you've got the source data. I then removed all the columns that weren't wanted, just leaving the ones that I need. And then I used this transformation option here, pivot column. I selected that and I clicked it, and it created this step here. Done. And then, you do your normal saving, it creates the sheet, and I've renamed the sheet, and then I could actually load that into Sims. Okay, so if you're not a Sims user, why might this be of interest to you? Well, it's actually a great way of viewing data as well. So, if someone gives you this Fisher Family Trust or data in this format, and you're finding it hard to interact with, you're finding it hard to compare the students and that sort of thing, you can flip it around. It's easy, really, really good. I also want to just talk to you about long format data a bit. So let's just have a look at the source data. In the database world, which kind of, quite frankly, people using Excel are going to have to become more familiar with as time goes by, there's a concept of a value having a unique identifier that tells you what it is, and that unique identifier would be referred to as the primary key. So the primary key for this piece of information would be the identifier of the student and the identifier of the subject. And because this table only contains PA and rank 15, that's it, just those two. If this table was longer, and at the moment it's only 1,700 rows long, but it would be possible to add other estimates for the same children for the same subjects based on different algorithms, so SX, and based on different ranks, and that would double the amount of data. And in that table, all of a sudden, this level here couldn't just be identified by the student name and subject, because you'd have multiple levels unless you also looked and filtered down to that. So in other words, if I filter down to student 1, I've now got just the student 1 data. If I filter down to a particular subject, I've used the primary key, 2 primary key fields to find that piece of information. If there were more rows that had different values here for the same student and the subject, I'd also have to filter on these values in order to get a unique value and actually fully identify the value that's being displayed. I hope that makes sense. If it doesn't, don't worry, but it's an ongoing theme that will come up numerous occasions, I'm sure. Okay, so I've said that this format of data is really good for analysis. Long format makes analysis easy. Well, guess what? When databases store data inside that is used by the users in the screens and the reports and all the analysis tools that database systems give their users, databases store the data in long format. So although when you're using Sims and various other systems, the screens you use might look like this, the mark sheets are very wide and have lots and lots of columns, and kind of, if you're a teacher, you know what I'm saying. Behind the scenes, Sims is actually storing its data in a long format like this. And when you actually open up a mark sheet, one of the things it has to do is take this data here and move it and create the screen for you that's got really, really wide format. So Sims is kind of inside itself got the ability to do what Power Query does. It's a lot cleverer, and it's really impressive actually. But it's worth having that appreciation that databases store data in long format. Okay, so here's where it actually gets really exciting. As an Excel user, I'm sure you're used to having lookup tables such as this one, which would let you go scan down this column here, find a value, a sublevel in this case, and then go across and find another value that's related or specific to that. So this sublevel here is a level 4, as is that one, but this is a level 5. Now, they've also got point scores associated with them, and they've also got other numbers that I use to convert and to do use more. You can work with numbers. You can't really work with this. This is just text. You can't add it up. You can't sum it. You can't compare it that easily. You have to work with numbers. So what schools will often do with their wide format data is, as well as having numeric data, in reality, schools work with sub-level textual data. Now, what I've set this spreadsheet up so that if I were to change this one, so at the moment you can see reading autumn text is 4A and reading autumn numeric is number 4. Well, if I change this to be a 5C, this automatically changes to a 5 as well. Now it's able to do that because it's using a formula that does a VLOOKUP. It's a VLOOKUP formula, and it takes this value here. This cell here uses the VLOOKUP format, as does every cell in this whole level area, and each cell looks for the equivalent textual value in the textual sublevels area. Hope this is making sense. And it goes to the lookup tables, it scans down and finds the number and then shows that number. All right. Now, if you're not familiar with VLOOKUP, I'm not really going to say much about it here, but here's some examples of VLOOKUP. There's the formula that I'm actually using, which wraps it in an if error, so that in the event the value that you type can't be found, instead of it showing NA like these two formulas would do, it just shows blank. And the other thing I want to draw to your attention is that the grey formula, instead of using the address like the blue formula is, it's using the table name. So this has actually been set up as a named range. So if you don't know about named ranges, worth finding out about them. It lets me identify a range or a cell by using a name instead of an address. So it makes formulas much more readable. But so yeah, what I'm talking about here is this whole looking up thing. The idea that to get this value, it needs to be looked up in another table using that value as the kind of identifier. Now, we're going to talk databases here, and you'll see where I'm coming from soon. The latest kind of buzzword in the Excel world is Power Pivot. It's getting really good. It comes with a data model. Only certain versions of Excel come with it, but I'm just going to give you a brief demo so you know what it's about. Now, in the database world, you might see diagrams that look a bit like this. Now, this table here represents the lookup table, and each text here represents a column. Now, this blob here represents the long format column table, and each text represents a column. Now, this black line represents the fact that this table can look up things in this table. So if I click on it, you'll see that it's saying this value here can be looked up in the table over here that's got an arrow at the end of the line, and you can then get any value from that table for it. So instead of using VLOOKUP, in Power Pivot's data model, you would put these blobs in and create the necessary create the necessary create the necessary joins, and then all of a sudden you can start using it. Okay, so I've done that, and I created it. It's actually very easy to create these blobs. So for instance, here, all I would do is come into the table, click Add to Data Model. For the long format data, you click in the table, you click Add to Data Model. Same with the lookup table, add it to data model, and then the blobs will appear, and then you have to create the join, and that is simply done. I'm going to delete it, show how easy it is. It's simply done by clicking on the column, hang around, and dragging it to the one that would normally be looked up, and it's done. And that has actually created that relationship for me. Okay, so how can I use that in Excel? Well, I would create a pivot table, of course, and you can see one I've made earlier. And over here, What you won't have seen before, if you've just used normal pivot tables, is the fact that there's more than one table available. At the moment, it's just using the long format and the sublevels table, but actually in the data model, there are lots of other tables as well, which I haven't shown you. Suffice to say, though, that you just drag the fields as you would do normally down into these areas here, which define the look and feel of the pivot table. And what's nice is if that, as you can see, subject, special needs, and term come from this table, and the level comes from this table. But if I want to get a piece of information from that, say the sublevel as a number, sorry, bad example. If that should be count as student rather. So if I wanted to take the textual sublevel from here and go to the lookup table and get the point score, it does it for me. So there's the point score, and there's the count of the number of kids. So I'll get rid of that. Now, you might be looking at this thinking, hang on a second, something fishy is going on here. Well, remember, this is an Excel table. This was based on an Excel table. It's been put into the data model, and we actually did some VLOOKUPs in that Excel table to actually take the textual level and find the level. So this has actually got the level in it, but it needn't have, because if I wanted to, instead of getting the level from there, I can get the whole level from the lookup table. You may have noticed this column here, it says get point score, and you're probably thinking, what the heck's that all about? Well, I showed you that the point score's here in the lookup table, but actually within the data model itself, it is possible to, in one table, find information from another. And I'm just going to show you how that's achieved, and just so you get a bit of an appreciation, more of an appreciation of what's going on in the data model. So as well as this view, we've also got the data view, which simply gives you a tab down at the bottom for every different table you've got. So there's the lookup table, and there's my long format table. And sure enough, these columns here are all the ones that are in Excel. And if you change the values in Excel, these will change as well. It's all linked and behaves as you'd expect it to. And the column names will change, and generally speaking, it's quite well behaved. This column here is new, get point score. So let's click on it and have a look. And you'll notice that a bit like Excel, I can enter a formula, and it uses this function called related. Now, related is a DAX function, which is a data model function. And all it does is it says, I want you to go and find from another table in the data model that field there, the point score field, and you need to go along the links. So in other words, it does the equivalent of doing a VLOOKUP on that in the lookup table, and then it displays the value. There's shed loads more you can do in here. I'm not even going to go there now because it's a massive topic, but just to give you a heads up of what's going on, what's really nice about putting data into the data model is that you actually don't need to put it into Excel sheets. So you can have lots and lots of tables in the data model that aren't shown in Excel, and because the Microsoft team have done an amazing work, it actually compresses it ridiculously. So instead of being a 10 megabyte file, it might only be 1 megabyte. And not only that, it makes it much quicker to use because it's designed specifically for aggregating and summarizing data, and it's in a columnar database, which is all vertical data, and it all gets pretty impressive when you start finding out about it. But all you really need to know is Excel's got a lot more to it now, and it's got some great features that work really, really well with long format data. However, for viewing and giving your users a nice user experience, you still might want to create wide format data. Try and get a database to do it for you if you can, or resort to using Excel if you have to. And I just want to show you a couple of features that I've put into this wide format. So things like adding buttons to hide column sets. So I'm now just looking at the behavior. Really, really useful because, quite frankly, you can get loads and loads of columns if all the information for one child is always in one row. You've probably seen these auto filter type things, and I mentioned earlier about filters, but all they do really, all these special slicers rather, all they do is they apply a filter here, which is an also filter, which you can add to ranges here and that are shown with data that's been converted to a table automatically. Couple of other things for those of you who might find this useful. Count A counts stuff. Count visible, well, I've used subtotal to count just the visible rows, and that enables me to give a percentage of the visible rows. So 21 out of 224 is 9.4%. So subtotal is a really useful function if you don't know it. Worth mentioning that in the past, people might have used COUNTIF or SUMIF just to summarize values in a column that match criteria, in this case 5. So this is counting reading in the summer that are level 5 and giving me 17. And that's giving me similar information that a pivot table would give me, but it's a lot harder to do and it's less flexible. Okay, so I want to end by just talking about how Sims stores data and looking at very long format data. So long format that we've used to now has looked like this. Okay, so I've copied that format into here. So you're familiar with, you know, the idea of having student details, a column with subjects, a column with which term, and a textual level, and all the benefits that having data in that format brings. Okay, in reality, it's not quite the whole picture because this kid here is actually a year 8 student, and this is actually his year 7 current level in the autumn. So in order to make sure that it's clear, we'd have to add these columns to the table to tell you that this value has a primary key of, or identifying values of which student, which subject, what type of grade, while he was in which year and which term. So these are your key values. Okay, and so we're starting to get quite long here. You know, you can see what's going to come next. You know, he's got lots of data for year 7 and year 8. He's got it for a lot more subjects than maths. So he might also have, as well as current levels, he might also have targets. So, you know, this is getting very, very, very long. And as well as targets, actually, he might have projections in each term as well. So what's he going to get at the end of the year? And in Key Stage 4, he might have an exam result, or he might have a mock result. Or there might be other targets like aspirational targets. So it might be actually for each subject, for each term, you have maybe 5 bits of data plus any homeworks and courseworks and things like that. So there might be 20 bits of data for each child every term or more. That's a long, long, long list. But you don't need to worry because you can use filters just to go, I want to see the current levels. And then you're just looking at the current levels. I'm not interested in his year 8 data. I just want the year 7 data, and that would limit it just to year 7. I only want to see the maths subject, and we only got one kid in this list, but it would actually show all the kids in while they were in year 7, what their maths current level was in autumn. You might actually then filter to which year they're currently in, and you need to add a column to do that, but you get the idea. You might, however, you need well-structured data to do that, and it is key having separate columns with a value that represents a particular piece of information. So these values here are all subjects. These define what type of grade. It seems obvious until you start looking inside Sims and you see what they've got. So let's just go back to our basic data again, and I'm going to show some Sims data. So in the Sims data model, which is where it's storing its data behind the scenes, yes, of course, it has got the student information. Yes, of course, it has got the textual value. But very, very, very unfortunately, these two columns here don't exist separately. How they exist is as a piece of text that someone's typed in separately, and that defines what this is. So you can still read it. I'm a human being. I'm not stupid. That's reading current level, year 7 autumn. But unfortunately, computers aren't good at dealing with things that people have written. And you might notice that the person who set these lists up has accidentally typed LVL there rather than level. They've used the word maths and mathematics, so the computer will think they're different subjects. Here, there's no space before the year 7. Um, so you can imagine this list here in my school. Um, Underlying this, there was a list of what they call result sets, which had 6 in every year. So there were 36 rows. In here, the situation was even worse because we had 10 subjects in each year. So, and each subject had projected grade, current level, target, and another target. So 4 for every subject. So 4, 5%, 40 in every year. And it gets even better because we had 6 years. So, you know, do the maths. We had 240 in that list. And okay, you're thinking, well, yeah, okay, but we can live with that, can't we? Well, not really. Sims does crazy stuff to get around this flaw, and it involved, when I set Sims up in my school, it took us 60 man days just to create the screens, because you have to create a separate screen for every single subject in every single year, and in some cases in every single term. And all those screens, well, all the key stage 3 screens for year 7, 8 and 9 are identical, and each one takes an hour and a half to set up. I'm not going to go on there, but just to say, if you're dealing with Sims data, all of a sudden you're going to have a bit of a shock, because you're going to come up against this. When you look at your wide format data, up here, it will say something like year 7 autumn reading current level, and it will be text. Fine, the users can read it, but if you want to put that into wide format, all of a sudden you're going to come across lots of difficulties. There are ways around it. They're not really acceptable. What should be happening is that Sims should be addressing this issue. The way I got around it in my last school was I had a naming convention, and I could then use the spaces as delimiters to get the information out that I needed. But it's crazy, crazy situation. So at this point, you're probably thinking, why have I shown you all this really good stuff in Excel, or how you can get wide format data, put it into long format, create lovely dashboards that do wonderful things for you, and got this data model thing that I might use in the future to make it even more powerful, and I can do great things with data, but you can't do it with Sims. Now, if you're a Sims school, you may be quite upset about that. And when I was at my last school and we were setting up Sims, I was ridiculously upset about that. And that's where my very first slide comes in. You know, what you'll find is that gradually schools are not using Sims Assessment Manager. They're using other tools to do their assessment. They're using the likes of Formatrix, PARS. They might even switch from Sims and use Progresso. They're using DataSecEd, which is £6,000 a year, and those are all based on Sims, or they're switching away from Sims totally and using a separate system such as Go for Schools. And guess what? It does a lot of the things I've been showing you in Excel already. So what's the solution, guys? Do you keep struggling with Sims? Do you keep working with their poor data structures and all the limitations they're going to impose on you in Excel and these add-in software that are going to have to kind of massage this and extract information and work out what's going on and then go from there, and they're going to have a hellish time and not really going to be able to do that much more? Or do you kind of just forget Sims exists and get on with using a different assessment tool which works well? Okay, so that's what my next video is going to be about. I will pursue the train of thought I've just introduced to you there. I will demonstrate Sims screens, and we might even take a look at Go. I hope you've enjoyed this presentation. Good luck with it. I just want to say that all the technical things that I've been demonstrating, there are shed loads of examples here on the Excel is Fun YouTube channel. and lots of playlists that you'll be able to find out about things. But as you can probably understand, it's not really my motivation to show you the technical details of Excel, but really to help you understand the limitations of Sims. Thanks for your time.